And so I'm going to do it again, something like, let's do x squared minus 3x or something like that. Whatevs. And I want to come back here. I want to rotate this dude, you see, this piece in here. I want to rotate it around this axis here. It'll be like a football. Yeah, you're right. And so we're going to chop it thusly, of course, which is a dx, of course. Right. And so how will I find this volume? Well, it's pi times the radius squared dx from 0 to 3. And that part's easy. And so let's do it. And so I FOIL it out, x to the 4th minus 2x cubicled plus x to squared. There you go. Just FOIL it out. And then antiderivatate, 143 over 5, whatever that is. 3 cubed is 81, times that's 162 over 4, and plus 9. And whatever this comes out to be is whatever our answer is. And so why don't someone use a calculator or cell phone or what have you to punch that out? That'd be swell. So maybe someone who's not taking notes could run a calculator. That'd be awesome. The rest of us will just write crap down. Yeah, nice. That's hot.
Is that a 5 or a 9?
That's a 9. What are you reading about?
80.1.
Is that your Twitter feeds? Your Vines? Your what have you? What is it? 80.1?
Before times it by 5.
Oh, so 240 something? Times it up.
51.64.
There you go. That's key. Units, of course, cubed, because it's volume. Labs. Listen, whatever. It's whatever. If you can't run a calculator to crunch things down, you've got issues. Okay, whatever. Now here's my deal, Nathan. What if I take that same area, this bit right here? What if I rotate it around the y-axis instead? What? But Mr. Groom, you'd have to chop it thusly. You're right, I would have to chop it like that. Hey, that's going to be a problem. Now this calls for a new graph, because that just sucks. Now, those are totally, by the way, symmetrical. You would chop it thusly, and you're like, oh, there's my dy. But dude, if it's a dy, that means I need to have a function of y in here. Are you effing kidding me? Because that means y is equal to x squared plus minus 3x. I'm going to have to solve for x there. You're going to have to get x equals. Can you do that? Can you do that? Well, trivia question. You can. Do I want to? No. Frequently, I can do things that I don't want to do. There are some times when it's just flat out impossible. This sucks. So what I'm going to do instead is I'm going to look at it this way. I'm going to use the shell method. Whee! And right there, what you see is a cylinder. Not unlike this fella. And notice that the thickness is a very tiny thickness. You mean like a dx? Mm-hmm. And so to get your 3 dimensions, you unfold this, and you have a circumference of a circle times a height. The height, of course, is f of x, right? This is your height. And your radius here, of course, is, well, how far out are you? Well, it feels like that's just some x value, yes? And so what this is going to end up becoming is not like that. That's gross. So it ends up becoming 2 pi times the radius times height. That's how we find the volume of a cylinder, yes? So in this case, it's going to be 2 pi times whatever the radius is. In this case, it's just going to be a good old x. What are you doing?
So the rest of my class is doing SBAT. So Patterson went, oh, hey, I might sit in Groom's class and learn some calculus.
Sit over there somewhere. That's cool. Yeah, it's good times. Times my height, which is f of x. All right, so 2 pi times your radius. So that is the circumference piece times the height. And then the integral gives us our thickness piece. Yes? Nice. Well, that's pretty cool. So in this case, it's going to be 2 pi x times my function. My function, of course, is x, what is it, squared? No, crap. Oh, fart. Well, I don't care. Turns out this picture actually looks like this. Don't get angry. I know some of you are already mad. Chittick's not here, so that's good. Don't cry. It's the same picture. It just actually should look like this. It doesn't change our answer, okay? It just should have opened up. Does that make sense? Just shake your head, because I'm right. Okay. It's the same picture, it just opens up as opposed to opening down. Whoopee! Makes no difference. Should it have been a different picture on the other page, too? Yeah, but it's okay. We would have just rotated it up over the top, yes? In other words, it would have started on the bottom, it would have ended up rotating over the top. Same answer, though. So nobody cry, nobody change your answers. It's just a different picture. Now, here's my question. And yes, it does look a bit like a buttocks. Now, here's the deal. It's x times x squared minus 3x dx. And, of course, we're going to integrate from 0 to 3. From 0 to 3. So let's try this. So you mean all I got to do is go execute? Freaking computer, I'm going to punch you in the face. Let's go ahead and distribute it out first. Richard, what do you have this period? So you're just not going to go?
I was there, but
Oops. Oh, okay. Well, that's cool. Yeah, the vector sector left. They went down to do their own thing. So 81 over 4 minus 27 times 2 pi, yes? I don't know what that is. Someone help me out there. Ooh, this might not be bueno at all. Oh! 81 over 4 is right. Oh, that's 3x squared. That's right. Oh, wait, time out. There's a bit of a small problem. It's not a big problem. It's a small problem. Let's talk about this. Let's talk about this region here. Okay? This region in here. Okay? Let's look at him for a minute. Do we see him? Now, if we see him up here, we immediately think what? What do we think here? We just think that it's this guy minus this guy on the bottom, yes? Right? Oh, it's this guy minus this guy on the bottom, right? But the guy on the bottom is 0, yes? Yes? And so, if you'll notice, if you keep going on this deal here, what are you going to end up with an answer down here? You're going to end up with what? A negative. And that's a bit of an issue, yes? So if I had looked at this slightly differently, my function then should have been, my region should have been this, yes? Which would have ended up being negative x squared plus 3x, which would have just changed my signs is all. That's no biggie. By the way, this will happen to you. I didn't do it on purpose. I never do, because God knows I screw up enough without trying. So there's no reason to try to screw them up. You will screw them up too. It's going to be 27 over 4 times 2 pi. So it's going to be 27 pi over dos. That should be our answer. Anyway, same answer, just the opposite, right? It's not negative, it's positive. Okay? If it happens to you, just be aware of that. I'll do a good one in a minute, okay? Don't get mad. Don't get mad. Don't be mad. Don't be mad. All right. So let's do another fun one here. So look at this problem right here. Square root of x, eh? Nice. Nice. Here is x minus 1. They cross somewhere. I don't know where they cross, Jacob. I don't really care right now. We'll figure it out in a minute. Now, I would like to take take this piece right here, and I'd like to rotate it around the y-axis. Therefore, it will look like this. Oh my gosh, it's like a heart or something. Yes, like a heart or something. About as good as I draw them normally. Now, I'd like to find a volume of that. But Mr. Grum, that if you were going to do it the disk method or the washer method, you would have to solve for what you'd have to solve for x in both of these cases. Now, is that possible to do? Yes, it's possible. Do I want to do it? Not particularly. Now, notice that this lower region is just a triangle, yes? It has a radius, right? It has a radius from there to there. It's a radius. It's fine. It's perfectly hunky-dory. Not a problem. And so if you were going to do this, you need to solve this. You'd have x is equal to y squared. And that's, I'm sorry, that's the wrong one. This one up here would be equal to x equals y plus 1, right? Right? So when I look at this, it has a radius. This radius is that function right there. Okay? And so you could do this way. You could say, well, it's equal to pi times the radius squared dy, and then go from -1 up to 0. And that would give you this region down in here. And that's totally fine. But then the upper region you'd have to do differently, because you have to do pi, and you'd go from 0 up to wherever they cross. I don't know what this is yet. We'll figure that out momentarily. And then you'd have an inner radius and an outer radius. So your outer radius would still be y plus 1 squared minus your inner radius, which again would go from the same value, 0 up to a. And then your inner radius would be x equals y squared. And I could do it, and I could do it in two pieces, and it would work. But that's more work than I care to do, thank you very much. So I'm going to go ahead and do it this way, just to prove that it's possible. Then I'm going to show you how the shell method is so much better. Oh my gosh, it's so much better. It's so much better. So let's try this. So let's go to Desmos and ask Desmos. So what are my two functions? X minus 1 and squirt x. So look where they cross right there, yo. They cross at 1, give it to me, 1.618. Why are you paying attention to y's? Because we're doing dy's this time, yes? So when I look at that, I'm going to come back over here. 1.68, or whatever I said, 1.618, something like that. Somewhere in that ballpark. And I'm going to go ahead and integrate these guys. So this top one is pi. Of course, it's y squared plus 2y plus 1 dy, -1 to 0. Y cubed over 3 plus y squared plus y from -1 to 0. And so, of course, that is at the top end a bunch of zeros, minus. And then it's -1, so it's going to be -1/3. And then it's going to be +1, -1, so just 1/3, right? I feel like that's right. So it's going to be 1/3 pi on that top end, something like that. That's the bottom piece. That's this bottom bit. By the way, does that shock me? Because what is this going to be when you wrap it around? You're going to have a cone with a radius of, at the top, 1, and a height of 1. And how do you find the volume of a cone? Pi r squared h. So divided by 3. So 1/3 pi. Not shocked by this. Now this one here. I don't know if I'm going to be shocked by it or not. But listen, it's going to be the same freaking antiderivative, is it not? That piece is the same. So I'm just going to go ahead and cheat and use it because I feel like it. Right? That's after I antiderivatate. So 0 and 1.618 or whatever it was I said, times pi. And then minus, and I'll just put a big fat pi around the whole shebang. And this is y to the 4th, so it's going to be y to the 5th over 5. Or something like this. And somebody with a calculator want to help us out. Plug in that 1.618 garbage, if you would, please. That'd be swell. So I've got pi over 3 plus whatever this comes out to be. By the way, nothing too terribly different about this. This is going to give us our baseline. This is a gross way to do this problem. There's no way I would do this problem this way, given the choice, because this is a lot of work. But when I show you the shell method in a minute, you're going to be like, that's amazing. Yes, yes it is. That's so much easier. Yes, yes it is. What did you get?
2.218.
The whole thing? Just this pieces? Or the whole answer? Oh, this one is 2.21. That's cute. And what about the rest of this mess? Do we have it? I'm sorry. Well, how about, yeah, there you go. Angel not doing anything. Don't be all snooty there, Mr. Dodger boy. Just giving you crap, Hainsey. Just giving you crap, baby. Yes, they do. Well, did you get it graphed yet? Here's what I do. I just freaking graph this thing right there, right? And then I put an x equals 1.618 line in, and then it'll intersect right there. That's what I would do, because I'm lazy. 5.64. Whatever. If you minus them, you get 3.4 something. Pi plus pi over 3. And you could get the answer, and this is 10-ish, 10.11-ish, plus 1-ish is 12-ish. I don't really care. Okay, whatever. We'll see the answer in a minute. You're going to see it's about 12-ish on the other one, too. Okay? But notice there's a lot of moving pieces here. Am I right? I had a lot of... Ugh. Here's the better way, friends. Here's a better way. This is where this thing really shines. When I was a kid, I don't think they did a very good job of explaining this, because I was always like, it seems like a lot of work. Why make me do it that way? Because it's going to be really easy in about a minute. So shut up and pay attention. I don't know. There's your height right here. What is this height? I feel like it's the difference of those two functions, yes? So the height is going to be, which one was on top? Square root of x minus, was it x minus 1? Bam. That thing right there is my height. Yes? Now my radius, well, I'm just wrapping it around the, God, what is this? It's like day 1 of the years. And I don't know why it keeps doing that to me today, but I'm getting beyond pissed off about it. You son of a... From there to there is just x, yes? So therefore, that is our radius this time. 2 pi because, well, that's how it works, because 2 pi times the radius is that circumference. And we're going from where to where? Now notice, this time we're going from 0 out to here. We're going out this direction this time, because we're going to respect to x. And so that's 2.618. Yes? 2.618. You have email. Is that you, Hainsey? So this times this is x to the 3 halves. I'm going to distribute this negative through. And then that times that is plus x squared, or minus, you idiot, minus x squared. And so if I antiderivative, I'm going to get 2/5 x to the 5 halves minus x cubed over 3 plus x squared over 2, 0 to 2.618 times the whole shooting match by 2 pi. I have no idea what this comes out to be. That's a lie. It should be 12-ish. What did you say? 11.8. 11.8? Oh my gosh, that's 12-ish. Who saw that coming? This guy did. Wasn't that so much easier? Oh my gosh, that was so much easier. Now you feel like, Mr. Grimm, can you give me a reason why I would do one versus the other? I would love to. In general, here's some in general rules of thumb. Look, I have random f of x. This is important. I'm going to wrap it around a horizontal line. Boop. Right? That means if it were me, see, I'm going to do a dx like this, yes? This means I should go ahead and use the disk/washer method. Because it's already a function of x, yes? That's like possibility number 1, I guess, if you want to think of it. Here's possibility number 2. Hey, look, I have some random function of x again. Ooh, but this time I want to wrap it around a vertical line. Shut up. You see a vertical line? I want to wrap it around a vertical line? Wait a minute. That means I'm going to have to cut it like so. Uh-oh. That's going to be a problem, yes? So if you have a situation like this, where you have a function of x and you want to go around a vertical line, then I would use the shell method. That's just what I would do, because then I don't have to solve for. I don't have to turn around inside out and solve it the other way. Hey, what's thing number 3 going to be? Mr. Grum, what if I have a function of y? Okay, cool. But you want to wrap it around, quit it. But you want to wrap it around a horizontal. Hey, this is exactly what we just did a second ago with the other one, huh? Horizontal, right? This looks just like this guy here, right? So, again, shell. And of course, the fourth one is we have a function of y doing its thing, and I would like to wrap it around a vertical. And if this is the case, it's going to look something like this or whatever. Then this, I'm going to use the disk. What is your problem today? The disk/washer method. Okay, those are really the 4 things that can possibly happen. Okay. If you do that, you will save yourself a lot of algebra. That's not to say you can't do it both ways. Sometimes you can't. Sometimes you can. This last one I could have done it both ways. Why would I want to? That's stupid. Okay? All right. You good, Hainsey? See, before you pointed out that you were taking notes, I would have thought you were like doing something on your phone right there. Because you look like you're really into it. And then, no. Okay, it's fine. All right, so here is this situation. I don't know what it looks like, so I'm going to graph it on the Desmos real quick. By the way, I love Desmos for this deal. Hey, let's do e to the y plus 2 equals x. Are you going? You going somewhere?
Yeah.
Is it over?
I'm moving for fitness.
Oh, where are you playing at? Have fun. No, I'm saying ln of x minus 2. No, it's ln of x minus 2. Right? Now, could you solve for x here? Yes. It would be x minus 2, and then you take the ln, yes? Right? So, I mean, you could do that. I wouldn't, but you could. I don't want to do that much work. For instance, again, it is x minus 2. Oh my gosh, they're the same. Don't do that. That's dumb. Okay? Now, well, whatever. So let's wrap this baby, and let's also do x equal 3 or something. No, let's do, x equals 3. That's cool. What? And x equals 10. Why didn't it graph? Oh, it's right there in the corner. There it is. It got it. And let's do y equals a goose egg. Nice. So let's take this region here. Okay. And let's wrap it around y equals 11. So I'm going to go ahead and, or not y equals 11, you moron. X equals 11. There it is. There we go. Cool. So you can see what the picture is going to look like. It currently looks like this, and this, right? So we want this shape. We want this region right here, and we're going to rotate it around this line. So obviously it's going to look like this, and it's going to have a hole in the middle of it, yes? Okay. Now, so we wrapped it around a vertical line, right? So if you go back and follow the directions I just gave you, we had functions of y, yes? We had x was a function of y. And so if you have a function of y, and you want to wrap it around a vertical line, what should we use? Discs and washers or shell? Discs and washers or shell? I don't know. Where's my notes? So I have a function of y around a vertical line, discs and washers. Well, does that make sense? It's literally right there. So let's try it. You take bad notes? Oh, for God's sakes. Mr. Groom, can you explain again? Yes. Look, if I wanted to chop this thing, I would chop it like so, yes? That's a dy, isn't it? Meaning that if I was going to play the game with discs and washers, I'd have to be integrating with respect to y. The only way I can do that is if I have a function of y. All right, let's do it. So, but wait a minute. Isn't there going to be an inner radius? Yes. And an outer radius, that is from here all the way in there? Yes. So let's talk about that. How far is it from here to here? It's 1. Is it always 1? I feel like it is always 1. That's right. It is. So that's my inner radius squared. Right? So then, and then, let's do the other one. What's my outer radius? How far is it from here? God, I'm going to punch something. How far is it from here at 11? You son of a worthless pig. How far is it from 11 back to anywhere on this line? Well, I don't know, Mr. Groom. I do. Because this line is x is a function of y, yes? Right? And so I feel like it's 11 minus whatever this function is. That will tell me where I am on the x-axis. That is my outer radius, in other words. Yes? Got it? So let's try this. Now, some of you will subtract it backwards. Some of you will take f of y minus 11. Do you know what that'll happen to you? You will get a negative answer when it's all done. Flip it around. That's literally all you have to do. Been there, done that. It's not hard. So, squared. Pi r squared, right? So this is going to be pi. Now, where are we integrating from, Mr. Groom? From 3. No, are we going from 3 to 10? No, those are x's, Mr. Groom. We should be going from where? On the y's from, from, son of a gun, from 0 up to wherever they meet right there, yes? And so going from 0 up to 2.079er. 2.79er. Okay? So I'll do the hard one. So this is y, 0 to 2.79. So this is just 2.79y. Or 2.79 pi, I mean, you idiot. There you go. Now this one over here, this is going to be gross. Because what is our f of y? Our f of y is, wasn't it, e to the y minus plus 2? Plus 2. The original function is plus 2. So this is going to be 9 minus e to the y squared is what we're going to be doing with. That is our actual function. So if you FOIL that out, you're going to get 81 minus 18 e to the y plus e to the 2y. All right. Okay, so here's the hard one, Brooke. 81y. Good job. Good job. Minus 18 e to the y. Nice job. Had a kid. And then plus a half e to the 2y. Is that right? Chain rule. From 0 to 2.79er. Of course, course, we will not get 0 on the bottom. Pay attention to that. Some people always mistakenly believe we will get 0. We will not get 0 on the bottom, yes? Because this is going to be 1, so you're going to get 18. This is going to be, of course, 0. And this, of course, will be a half. So I'll do the hard part. Of course, that's the bottom end. Somebody else do the top part. That's the tricky part. So put a 0 in. You're going to get 0 minus 18 plus a half. And if you put 2.79 in there, what do you get? It's a fairly large number, I think. Hmm. 56.43. And so 56.4. Oh, you sack of manure. So this is negative 17 and a half. So it's just going to be, so it's going to be minus 17 and a half. So plus 17 and a half. So 56.43. Why is that negative? That feels funny. Anyway, so let's see. So yeah, so minus and minus. Yeah, so plus 17 and a half. That's weird. It feels a little awkward, but whatever. Plus that out. What do you get when you times it out? So it's
232.57.
sure, or in that neighborhood, in that ballpark. So my goal here is to see, can I tell which way to do which one? And that's what I hope when you walk away, you're like, oh my God, this is so easy. That's what you're going to say before you leave, I promise. Now, you're like, do another one. Hey, that's my job. Here's x squared. Here is half x plus 1. Oh my gosh. Can you take this region here and rotate it around this line here, x equal 5? Yes. Isn't that pretty much like we just did? Well, no. What's different this time? It's f of x. So because it's f of x, we should be using the shell method. And so our height, what's our height going to be right here? What is that height going to be? Half x plus 1 minus x squared. That's my height. This next step is the trickiest piece. Oh my goodness. How far is it from this line over to any random value here? How far is that? That's my radius. How far is that? That's the hardest part. Well, I don't know either, Hallie, but I know this, Hallie. By God, that's x right there. Yes? Yes? And I feel like from here to here is 5. So I feel like my radius probably ought to be 5 minus x. Okay? That is the hardest part of this thing. It's the hardest part. By far. It's not even close. Now, what are we going to integrate from? We're going to go from 0 here, yes? Over to where they intersect. Which I don't know where they intersect. And I'm too lazy to do algebra, so I'm just going to go graph them. So no, that's e equals stupid. 0.5x plus 1 x squared. Booyah. 1.281. How am I going to take the integral of this freaking thing, for goodness sakes? We have to FOIL it out, yes? And so it's going to be 2.5x plus 5 minus 5x squared. And then you're going to get a negative x squared over 2. And a minus x and a minus x, no, plus x cubicled dx. Give it to me, you hippie. 1.281. Right. We can clean up a few things here. 2.5 minus 1 is 1.5x. And this minus this is 5 minus negative 5.5. So it'll be 11 halves x squared. And then we just got another We got an x cubed here somewhere, and we got a plus 5 somewhere. That sound reasonable? Yeah, it sounds right. All right, let's integrate this sucker. So, oh dear. Shouldn't this be a 3/2 x, Mr. Groom? I feel like it should be. I feel like it was supposed to be. It is. So let's do that. So that's going to be, I feel like, just 3x squared over 4. Is that right? Minus 11x cubicled over 6 plus x to the foe over foe plus 5x from 0 to 1.281. And if we plugged all that mess in, we'll be home free. But I kid you not, the trickiest part is when you're rotating over a vertical line, or even a horizontal line, that is not the x or y axes, because you have to pay attention to what is that radius. And you will screw it up, because everybody does. And then you'll get a negative, and you're like, oh, I did it wrong, I got a negative. That's because your radius, instead of being like 10 minus x or whatever, it should have been x minus 10 or vice versa, okay? So clearly on this one, notice that we did 5 minus x on this one, yes? But what if the original function had been out here? What if the original function had been out here? Well, then it would be x all the way out to here, yes? And it'd be only 5 to here. In this case, it'd be x minus 5 for the radius. Just pay attention to that. I can't give you like a zillion little itty-bitty deals. Just look at it. What did you get?
I don't know. I screwed up. Turned out negative.
Yeah, well, whatever. Let's look at it. I guess I'll break out my calculator. It's kind of late in the day to get started, but I guess I'll do it anyways. Because that's what a good teacher would do, Mr. Groom. No, not an 83. This freaking thing hates me. Should be about 28-ish. Yay-ish. All right, it's pretty good, whatever, I don't know. I just work here. Okay. That's the game. That's all there is to that. Again, when you're doing these, the hardest part is figuring out what the radius is when you're not wrapping around the axes. The second hardest part is keeping this little stupid thing in front of you. Keep these 4 what-ifs in front of you. If you have them in front of you, it'll tell you which way you should do it. That's the easiest way to do it. Okay? I'm not saying you can't. I'm not saying you can't solve for x equals if you have y equals function, but why would you want to? Okay? We were always taught, well, in this section we do it this way. Why? Because that's, I don't know, it's just a different way to do it. Does it always work? And the teacher always say, well, yeah, it always works. Well, yes, in theory it always works if you can turn the function inside out and solve it the other way around. Sometimes you can, sometimes you can't. But here's what I don't want to do. Most of the time I don't want to do it. So I'm too lazy. So if I keep track of these 4 relationships, it's a lot less algebra. Just jump in and go. Okay? Now, granted, Mr. McAtee, who's teaching next door to me for years, he hated the disc and washer method. Why, Steve? Because you have to square it. I'm like, so? It's easier this other one. I'm like, well, yeah, but you got to solve for the other variable. He's like, stupid. I'm like, whatever. To each their own. Okay? I'm telling you this is the easy way to do it. Okay? If you keep these 4 deals in front of you. All right? Now, the second assignment you have is on the is basically just going to be the shell method. Okay? So just be